Second thing which we want to look at in the big data technologies is the schema-on-read. So traditionally, I mean, if I would give you the choice today to try to query the data, any data, just even tabular data, on a database or in plain files, what would you choose? Naturally, you would choose the database. It's much easier to just run a SQL query. However, the big data tools in the Hadoop ecosystem, the processing tools like Hive and Spark and so on, made it easy to work with plain files that were not inserted in the database. So you did not need to create a database nor insert files into the database. Even in Hive, which was like SQL, you could refer to that as an external table and work with. And that was the idea of schema-on-read. So the schema of a file, it's either inferred or specified, but the data is not inserted. It's just pointing to it to kind of check against the specified schema and be able to work with it. Let's take a closer look here. So in Spark, and I am sure you have seen already that, like spark.read.csv, and you say infer schema. And the idea would be that if you infer the schema, you can see that some types are correctly inferred, and some types, like for example, the payment date is inferred as string for the lack of better knowledge and simplicity, and then we might, of course, cast that afterwards, or we might decide to not leave it up to Spark to guess this. Sometimes actually schema inference won't work. Like if you have many types, the data is not very clean, and you have many types in the same column. You have like a float and a double and a string. It can happen, and that can confuse Spark, and not always the schema inference would work. But then you can go and specify the schema, the column for each type here. And also you can say, which is very important, what happens if I find a row which does not conform to the schema? And you have also the policy of like drop malformed. So you can say, okay, ignore it. Or you can say fail and stop the whole process. Or you can say just leave it and put this row with, fill this row with nulls. So I would be able to know that how many are bad or malformed. And luckily, if you apply that, you get properly enforced types. So not because it's schema-on-read that we're going to make things messy. We still have a little bit of control. Once the data is pointed to or by a schema, inferred or specified, and it's loaded into a data frame. And once you have a data frame, you can just go and do direct querying on the fly, no databases, no insertions. Even better, that you can even write SQL by just taking that data frame and register it as a table, and start doing normal querying as if this was a table in a database. While again, it's still querying on the fly, and there are no databases, no insertions.